NASA's THEMIS mission has overturned a long-standing belief about the interaction between solar particles and the Earth's magnetic field. The Earth's magnetic field is like a giant bar magnet. This magnet forms a protective field around the Earth, shielding us from the solar wind that is constantly streaming towards Earth. This shield is called the magnetosphere.
The solar wind is primarily composed of protons and electrons, charged particles streaming out from the sun. Some of those particles have very high energies, radiation energies, and they can damage astronauts and spacecraft. We are shielded by our Earth's magnetic field most of the time. However, a small fraction of the solar wind particles get into the Earth's magnetic field, are energized, and become the Earth's radiation belts, which can damage spacecraft and harm astronauts.
But the sun has a magnetic field of its own as well, which the solar wind carries outwards towards Earth. And the THEMIS spacecraft fleet recently observed that 20 times more solar particles get into the Earth's magnetosphere when the sun's magnetic field aligns with that of the Earth than when they're pointed in opposite directions.
In the past, researchers found that the energy from the sun gets into the Earth's magnetic field during periods when the sun's magnetic field points southward. Here we found that the particles get in, the plasma, the particles from the sun, get into the Earth's magnetic field when the sun's magnetic field points northward. For a long time, people have known that the location where particles and energy get into the Earth's magnetic field depend on the orientation of the sun's magnetic field, but they just hadn't realized how many particles get in for the northward orientation of the sun's magnetic field.
So what do these new findings mean for us here on Earth? Well, with this new information, scientists can make better predictions about when solar storms will be severe, meaning we can better prepare for the power outages, satellite damage, and other problems that these storms can often cause.
A giant breach in Earth's magnetic field. Presented by Science at NASA. December 16, 2008. NASA's 5 THEMIS spacecraft have discovered a breach in Earth's magnetic field 10 times larger than anything previously thought to exist. Solar wind can flow in through the opening to load up the magnetosphere for powerful geomagnetic storms. But the breach itself is not the biggest surprise. Researchers are even more amazed at the strange and unexpected way it forms, overturning long-held ideas of space physics. At first, I couldn't believe it, says THEMIS project scientist David Siebeck of the Goddard Space Flight Center. This finding fundamentally alters our understanding of the solar wind magnetosphere interaction. The magnetosphere is a bubble of magnetism that surrounds Earth and protects us from solar wind. Exploring the bubble is a key goal of the THEMIS mission, launched in February 2007. The big discovery came on June 3rd of the same year when the 5 probes serendipitously flew through the breach just as it was opening. Onboard sensors recorded a torrent of solar wind particles streaming into the magnetosphere, signaling an event of unexpected size and importance. The opening was huge, 4 times wider than Earth itself, says Wen-Hu Lee, a space physicist at the University of New Hampshire, who has been analyzing the data. Lee's colleague, Jimmy Rader, also of New Hampshire, says 10 to the 27 particles per second were flowing into the magnetosphere. That's a 10 followed by 27 zeros. This kind of influx is an order of magnitude greater than what we thought was possible. The event began with little warning when a gentle gust of solar wind delivered a bundle of magnetic fields from the sun to Earth. Like an octopus wrapping its tentacles around a big clam, solar magnetic fields draped themselves around the magnetosphere and basically cracked it open. The cracking was accomplished by means of a process called magnetic reconnection. High above Earth's poles, solar and terrestrial magnetic fields linked up or reconnected to form conduits for solar wind. Conduits over the Arctic and Antarctic quickly expanded. Within minutes, they overlapped over Earth's equator to create the biggest magnetic breach ever recorded by Earth-orbiting spacecraft. The size of the breach took researchers by surprise. We've seen things like this before, says Rader, but never on such a large scale. The entire day side of the magnetosphere was open to the solar wind. The circumstances of the breach were even more surprising. Space physicists have long believed that holes in Earth's magnetosphere open only in response to solar magnetic fields that point south. The Great Breach of June 2007, however, opened in response to a solar magnetic field that pointed north. To the layperson, this may sound like a quibble, but to a space physicist, it is almost seismic, says Siebeck. When I tell my colleagues, most react with skepticism, as if I'm trying to convince them that the sun rises in the west. Here is why they can't believe their ears. The solar wind presses against Earth's magnetosphere almost directly above the equator, where our planet's magnetic field points north. Suppose a bundle of solar magnetism comes along, and it points north too. The two fields should reinforce one another, strengthening Earth's magnetic defenses and slamming the door shut on the solar wind. In the language of space physics, a north-pointing solar magnetic field is called a northern IMF, and it is synonymous with shields up. So you can imagine our surprise when the northern IMF came along and shields went down instead, says Siebeck. This completely overturns our understanding of things. These northern IMF events don't actually trigger geomagnetic storms, notes Rader, but they do set the stage for storms by loading the magnetosphere with plasma. A loaded magnetosphere is primed for aurora borealis, power outages, and other disturbances that can result when, say, a coronal mass ejection hits. The years ahead could be especially lively. Rader explains, "We're entering solar cycle 24. For reasons not fully understood, CMEs in even-numbered solar cycles, like 24, tend to hit Earth with a leading edge that is magnetized north. Such a CME should open a breach and load the magnetosphere with plasma just before the storm gets underway. It's the perfect sequence for a really big event and a grand display of northern lights." Siebeck agrees. This could result in stronger geomagnetic storms than we have seen in many years. Stay tuned to Science at NASA for more results from the THEMIS mission. This story was written and read by Tony Phillips. To find more Science at NASA stories on the Internet, please visit science.nasa.gov.